Okay, this is part 2 of lesson 6-4. We're still talking about rectangles. Here we're going to talk about how to prove parallelograms are rectangles. So we just talked about the properties of rectangles, and we said they have all the same properties of parallelograms, plus all four corners are 90 degrees, and the diagonals are the same length. Those are the only two extra properties of a rectangle that make a parallelogram a rectangle. So here we're going to talk about how to use the slope formula and the distance formula to prove that a parallelogram is a rectangle. All right, so example, quadrilateral ABCD has vertices at blah, blah, blah. Determine whether it's a rectangle, right? So when it just tells us like this, it doesn't even tell us it's a parallelogram yet. So we have to prove that it has the same properties as a parallelogram, and then we have to prove that it also has one of those extra properties that make it a rectangle. Either all four corners are 90 degrees or the diagonals are the same length. So method 1 is to use the slope formula, right? And remember the slope formula. I can write it over here to the side. Slope equals y minus y over x minus x, right? When we have 2 points that lie on a line, we use the y value in both points, we subtract them, and then we use the x value of both points and we subtract them, and that number gives us our slope, the rate that the line is going up or down, rise over run, okay? So this is just using the slope formula. The slope formula helps us determine if opposite sides are parallel, right? So first you want to have your parallelogram. Here they graphed it. You actually don't even have to graph it. You just know if, I always just kind of draw a rectangle. And it may or may not be a rectangle, but this is my quadrilateral. And then I always, A, B, C, D, give it corners. So no matter what my rectangle looks like, AC is always my diagonal. Up here, AC is a diagonal. DB is a diagonal here. DB, BD, same thing, is a diagonal, right? So it doesn't really matter which way your parallelogram goes. If you don't graph it, you can just kind of draw one. But we want to compare opposite sides, right? So AB is opposite of DC here. DC is opposite of AB. So we want to make sure they have the same slope. So we want to find the slope of line AD and the slope of line DC. Am I saying that right? Yes. So we find the slope of both, and here they're both negative 1/3, which means they're parallel. They have the same slope. So I know this guy, where's AD? This guy is parallel to this guy. And then I want to compare these opposite sides. For this to be a parallelogram, both pairs of opposite sides have to be parallel. Not just one set, both sets, right? So then the other pair of opposite sides are AB and DC, right? Or you can call them BA and CD, it doesn't matter. So then they found the slope of each of those sides. And if we compare those, again, they are the same. So we know those opposite sides are parallel. So all we've proven right now is that this is a parallelogram. Once we know it's a parallelogram, what else can I prove? Can I prove the diagonals are the same length? Or can I prove that all four corners are 90 degrees only using the slope formula? Well, if I'm using the slope formula, that's not going to tell me how long the diagonals are. So I'm not going to be able to prove that the diagonals are the same length, right? So the other thing I have to be able to prove then is that all four corners are 90 degrees. That's going to help me prove this is a rectangle or not. Top part tells me if it's a parallelogram, then I got to prove it's a rectangle. So for the corners to be 90 degrees, it means that one edge has to be perpendicular to the edge next to it, the line next to it, right? So this guy would have to be perpendicular to this guy. Perpendicular, remember, means that two lines intersect to form a 90-degree angle. Okay, so if this line's perpendicular to this line, it's a 90-degree angle. And in a parallelogram, if one of the angles is 90, that means all four are 90, right? So using the slope formula, it says consecutive sides are perpendicular here. We haven't proven that yet, so how would we prove? Well, this side is BA. BA has a slope of 3. This side down here is AD. AD has a slope of negative 1/3. So are 3 and negative 1/3 negative reciprocals? Are they opposite slopes? For them to be opposite slopes, you got to flip one of them upside down and then change the sign in front. So this is positive 3 over 1. If I flip it, I get positive 1 over 3. And if I change the sign in front from positive to negative, I get negative 1 over 3. So yes, these slopes are opposite. They are negative reciprocals, which means these lines are perpendicular if they have negative reciprocal slopes. So that makes this true. So the first part made it a parallelogram, proving that the sides are perpendicular makes it a rectangle. Okay, the second method we can use instead of slope formula is the distance formula. And the only thing distance formula measures is the length of a side, right? So we know parallelograms have both pairs of opposite sides congruent. They're the same length, right? To be a rectangle, that has to be true, plus the two diagonals have to be the same length, right? So we've got our parallelogram. You can just kind of arbitrarily draw one. Doesn't really matter where it's at. Give it two diagonals. Okay, so I got to make sure that AB is the same length as DC. So here's AB and DC. They both have a length of square root of 10. So they're congruent. And I have to make sure that AD is the same length as BC because they're the other pair of opposite sides. They also have to be congruent. BC is square root of 40. AD is square root of 40. They are the same. So both pairs of opposite sides are congruent. That means this is at least a parallelogram. Then we have to prove that the two diagonals are congruent. That will tell us that it's a rectangle, right? So one diagonal is AC. The other diagonal is BD or DB. AC, the length of AC is square root of 50. The length of BD is square root of 50. So they are the same. So if the two diagonals are the same, that means this is a rectangle, right? It is a parallelogram with congruent diagonals, so it's a rectangle. Okay, so that's all we're doing down here. It's going to tell us which formula to use, and then we have to figure out how are we going to prove it's a parallelogram and a rectangle, and we actually have to do it, right? So it's kind of tedious. We're going to start here with number 1, distance formula. The only thing we can prove with distance formula is length. So first we have to prove that both pairs of opposite sides are the same length. That tells us it's a parallelogram. Then we have to show that the diagonals are the same length. That shows it's a rectangle, right? So the opposite sides, same thing. If I sketch a little parallelogram up here, A, B, C, D, and then I draw my two diagonals. So the first pair of opposite sides are AB and CD, or DC. So I want to find the length of both of those, right? So AB, and I'm going to use distance formula. And remember the distance formula. I can write it up here for you. Distance equals the square root of x minus x squared plus y minus y squared. And the order of these don't really matter. Like you could have done y minus y squared plus x minus x squared. When you're adding, it doesn't matter what order they're in. But you're going to add your x variables together. Sorry, you're going to subtract your x variables and square it. And then add that to your y variables being subtracted and then squared. And again, you can flip-flop those orders. That's fine. All right, so for AB, x minus x would be negative 3 minus negative 3. Negative 3 minus negative 3. When I have a double minus, it comes a plus. And I square it. Plus, that's x minus x squared. And then y minus y squared is 1 minus 3. And if I simplify that, negative 3 plus 3 is 0. 0 squared is 0. 1 minus 3 is negative 2. Negative 2 squared is positive 4. This becomes square root of 4, which is 2. So the length of AB is 2. Now I want to find the length of the side opposite it, right? DC or CD. It doesn't matter how you name it. All right, so same thing. I'm going to use distance formula. X minus x squared, so 3 minus 3 squared, plus y minus y squared, 3 minus 1 squared. And if I simplify that, 3 minus 3 squared is 0. 3 minus 1 is 2. 2 squared is 4. Looks like it's going to be exactly the same. Okay, so I know I have one pair of opposite sides that are congruent, right? Then I got to find the other pair of opposite sides. So that's AD and BC. I'm going to run out of room. I'm trying to write small. All right. Oh, sorry. AD square root of, and I got to use my things over here, x minus x, negative 3 minus 3 squared plus y minus y, 1 minus 1. Okay, and if I simplify that, 3 minus 3 squared is 0, so I'm not going to write anything down. 1 minus 1, oh, sorry, this is negative 6, sorry. Negative 6 squared is 36, plus 1 minus 1 is 0, 0 squared is 0, so I don't have to write plus 0 here. And then the square root of 36 is 6. Okay, so the length of side AD is 6. Then I want to find the length of side BC. Same thing, distance formula. B is negative 3, C is 3, so I'm going to do negative 3 minus 3 squared plus, and then where did I be C? 3 minus 3 squared. Okay, then I can start simplifying. Negative 3 minus 3 is negative 6. Negative 6 squared is 36. Plus 3 minus 3 is 0. 0 squared is 0, so I don't have to write anything. Okay, so those are the same. So I know this is a parallelogram because both pairs of opposite sides are the same length. Now I got to figure out if the two diagonals are the same length. Okay, so I'm going to do that in a different color. So my first diagonal is AC. Oops. I know this seems super tedious. Oh, I totally messed that up. But you got to go through the motions, right? So for AC, A is negative 3, C is 3. So negative 3 minus 3 squared plus, and then my Y values, 1 minus 3 squared. The negative 3 minus 3 is negative 6. Negative 6 squared is 36. 1 minus 3 is negative 2. Negative 2 squared is 4. And when I add that together, I get square root of 40. Now, I can't evenly take the square root of 40. I'd get a decimal. So I'm just going to leave it like this. It doesn't really matter what the number is as long as it's the same as the other diagonal, DB or BD. So now I'm going to find the length of DB. All right, and that is, let's see, here's B, here's D. So I'm going to do negative 3 minus 3. Remember, it doesn't matter which x you start with first, but whatever x you start with first, you have to start with its partner y first. So I started with negative 3, doing db3, so 3 minus 1. Okay, negative 3 minus 3 is negative 6. Negative 6 squared is 36, plus 3 minus 1 is 2. 2 squared is 4, and I get, when I add those together, square root of 40. So they are the same. So since both pairs of opposite sides are the same and both of my diagonals are the same, yes, this is a rectangle. It said determine whether the figure is a rectangle. That was the directions here. So I said yes. Okay, it doesn't say determine if it's a parallelogram, but obviously to be a rectangle, it first has to be a parallelogram, and then you either have to prove that all four corners are 90 degrees or the diagonals are the same, okay? The next one here is the slope formula. I actually have two more, and I can post them all worked out for you, but I'm not gonna video myself working them out because it's the same thing as we did up here, right? It's just tedious. They may or may not be parallelograms or rectangles, right? You just have to do the work. Okay, so here I have to use the slope formula, not distance. So now I want to determine if both pairs of opposite sides are parallel. So does AB have the same slope as DC? Does AD have the same slope as BC? And then using slope, I have to figure out, are one pair of one pair of adjacent sides, are they perpendicular? Are they gonna form a 90-degree angle here, right? So I just have to compare this slope to this slope. And if they are negative reciprocals, then I know they're perpendicular, and that tells me this is a 90-degree angle. If they're not perpendicular, this is not 90, and then that would just tell me that it's a parallelogram and not a rectangle, as long as both pairs of opposite sides are parallel. Okay, so let's start there. Let's look at side AB. And I'm using the slope formula, which is y minus y over x minus x, right? So A, y, 0, B, y is 3, 0 minus 3 over negative 3 minus negative 2. And when I have a minus and negative, it becomes a plus. So that's negative 3 over negative 1 which simplifies just to positive 3. Okay, so that's my slope of AB. Then I want to find the slope of the side opposite it, which is DC. Okay, same thing, y minus y over x minus x. I'm going to do 5 minus 2 over, since I started with 5, I have to start with the 4 on the bottom, 4 minus 3. 5 minus 2 is 3, 4 minus 3 is 1. That simplifies to 3. So one set is parallel, one pair of opposite sides. Now I got to compare the other set of opposite sides. I'll do it in blue. That's AD and BC. So find the slope of AD. 0 minus 2 over negative 3 minus 3. And 0 minus 2 is negative 2. Negative 3 minus 3 is negative 6. And that simplifies to positive 1/3. Then I want to find the slope of BC. Y minus y, 3 minus 5 over negative 2 minus 4. 3 minus 5 is negative 2. Negative 2 minus 4 is negative 6. So that simplifies to positive 1/3. Good. So I know both pairs of opposite sides are parallel because they have the same slope. That tells me this is a parallelogram. Then I just have to compare just one corner here, one pair of adjacent lines. So I'm going to compare AD and DC. And again, we're trying to prove that all 4 corners are 90 degrees. And in a parallelogram, previously we learned that if one angle is 90 degrees, then all 4 are 90. They have to be. Okay, so we just have to prove that one angle is 90 degrees. So I'm going to compare the slope of AD and DC. The slope of AD is 1/3. The slope of DC is 3. Are these negative reciprocals of each other? Right, I can turn this into a 1. Did I flip it upside down? Did I change the sign in front? Well, it looks like I flipped it upside down, but both of these are positive numbers, right? So if they're both positive, they can't be perpendicular. Let's look at this for a second, okay? Think about on a graph. I know I don't have a graph here, but if my slope is 1/3, that means if I start here at this dot, I'm going to go up 1 and over 3. So it's going to kind of have that kind of slant, right? Up 1 over 3, up 1 over 3. That's what 1/3 is going to look like, okay? If I started at this same dot and my slope was 3/1, that means I'm going to go up 3/1. Just a little bit here, up 3/1, right? So my line's going to be kind of like this kind of look, right? Does that look like it forms a 90-degree angle? No. But what if it was negative 3/1? If I start at this dot and I meant to draw this line through this dot, sorry. But if I went down 3/1, down 3/1, and I drew a line through those, does this look like it forms a 90-degree angle? Yes, it does, right? So that negative sign makes a difference. If one of the slopes is positive, the other has to be negative. If the first slope is negative, the other has to be positive. They have to have opposite signs to form a 90-degree angle. This is not what we had. This is what we had, right? And that does not form a 90-degree angle. Okay, so even though they look close, they are not, this is not a rectangle. So out to the side, I would just write no. All right, so that's one example each of using the distance formula and the slope formula. Distance, you're proving first it's a parallelogram. You have to show both pairs of opposite sides are the same length. So you got to do the distance formula 4 times. And then to prove it's a rectangle, you have to also prove that both diagonals are the same length, right? So if those are the same length, then you know it's a diagonal after you've already proven it's a parallelogram. For the slope formula, you have to prove both opposite sides, both pairs of opposite sides are parallel, have the same slope. So this guy and this guy. And that shows it's a parallelogram. And you have to show that one pair of adjacent sides are perpendicular, that they have opposite slopes, negative reciprocals. Once you prove that one pair form a 90-degree angle, then in a parallelogram, we know that all the angles have to be 90 degrees, right? So then that would make this a rectangle, okay? Let me know if you guys have questions.